Venus, a detailed exploration. Venus, often referred to as Earth's sister planet, presents a stark contrast in terms of habitability. Despite its similar size and proximity to Earth, Venus stands as an inhospitable world, characterized by extreme conditions and numerous dangers that make human colonization a formidable challenge. Venus harbors an atmosphere dominated by thick clouds of sulfuric acid, and a dense layer of carbon dioxide. The atmosphere creates a powerful greenhouse effect, trapping heat and leading to surface temperatures hot enough to melt lead, exceeding 860 degrees Fahrenheit, 460 degrees Celsius. This extreme heat poses insurmountable challenges for human survival. The intense greenhouse effect on Venus results from the high concentration of carbon dioxide, preventing heat from escaping the planet. Unlike Earth, where the greenhouse effect is a crucial factor for maintaining a habitable climate, Venus experiences an extreme version, rendering its surface temperatures uninhabitable, and its atmosphere inhospitable. Surface temperatures on Venus are hotter than those on Mercury, the closest planet to the Sun. The crushing atmospheric pressure, approximately 92 times that of Earth, further exacerbates the inhospitality. Human life, with its dependence on moderate temperatures and Earth-like pressure, cannot withstand such extreme conditions. Despite Earth's reliance on water for life, Venus presents a stark contrast with its desiccated surface. Any water that may have existed has long since evaporated due to the intense heat. The absence of liquid water on the surface eliminates a fundamental requirement for human survival and habitation. Venus rotates on its axis in the opposite direction to most planets, a phenomenon known as retrograde rotation. This slow and retrograde rotation results in extremely long days and nights, each lasting approximately 117 Earth days. The prolonged exposure to scorching sunlight during the day and freezing darkness at night adds another layer of complexity to potential human adaptation. Venus' thick atmosphere contains clouds of sulfuric acid, creating an acidic environment. These clouds contribute to the planet's high albedo, reflecting a significant portion of sunlight back into space. The corrosive nature of sulfuric acid clouds poses challenges for any potential structures or equipment intended for human habitation. Venus experiences extremely fast atmospheric winds, reaching speeds of up to 360 km per hour, 224 miles per hour. These powerful winds can lead to turbulent conditions in the upper atmosphere, making the deployment and maintenance of floating habitats challenging. Navigating through such turbulent winds requires advanced engineering solutions. Venus' surface is marked by extensive volcanic plains and numerous large volcanoes, such as Maat Mons and Mons. The presence of these geological features indicates a history of volcanic activity. Establishing human colonies on a geologically active planet raises concerns about the potential hazards associated with volcanic eruptions and lava flows. Venus lacks an active hydrological cycle, with no evidence of liquid water on its surface. The absence of oceans, rivers, or lakes eliminates essential water sources for human consumption and agriculture. Establishing self-sustaining habitats without access to water remains a significant challenge for potential human colonization. The absence of a global magnetic field exposes Venus to the direct impact of solar wind. Solar wind erosion can strip away the planet's atmosphere over geological timescales, leading to a gradual loss of volatile compounds. Understanding this erosion process is crucial for assessing the long-term stability of Venus' atmosphere and its potential impact on human colonization efforts. Venus experiences a drastic temperature shift between day and night due to its slow rotation. During the day, temperatures soar to scorching highs, while at night, they plummet. This extreme variation adds another layer of complexity for any potential human presence, requiring advanced thermal regulation systems to withstand the stark temperature contrasts. The albedo effect on Venus, caused by its thick clouds reflecting sunlight, contributes to the planet's overall brightness. While this effect aids in preventing excessive heat absorption, it also means that less sunlight reaches the surface. This reduced solar energy availability poses challenges for potential energy sources, such as solar panels, impacting the feasibility of sustainable power generation. Venus is approximately 4.5 billion years old, similar to Earth in age. However, its evolutionary path diverged significantly. Venus underwent a runaway greenhouse effect, leading to the current extreme conditions. Understanding the geological and climatic history of Venus is crucial in comprehending the challenges it poses for human habitation. Venus is nearly the same size as Earth, with a diameter only about 650 kilometers smaller. However, its gravity is significantly weaker, around 90% of Earth's gravity. The combination of Earth-like size and reduced gravity could have physiological impacts on the human body, potentially affecting long-term health and adaptation. Venus lacks evidence of tectonic plate movement, contrasting sharply with Earth's dynamic geological processes. The absence of plate tectonics hampers the planet's ability to recycle and renew its surface, potentially leading to a stagnant geological environment. Understanding the implications of this tectonic inactivity is crucial for assessing the long-term stability of Venus' surface. Venus' surface is marked by a high density of impact craters, indicating a history of meteoroid and asteroid collisions. The constant bombardment has significant implications for potential human habitats, requiring robust structural designs to withstand the impact of debris and ensuring the safety of any colonization efforts. Venus lacks the rich diversity of resources found on Earth. The absence of easily accessible minerals, metals, and other essential materials poses challenges for constructing and maintaining human settlements. Any successful colonization effort would need to address the need for resource utilization and extraction from the challenging Venusian environment. Developing technologies capable of exploring Venus' atmosphere is essential for advancing our understanding and potential for habitability. Advanced probes and instruments designed to withstand the extreme conditions could provide crucial data for evaluating the feasibility of future human missions and habitats. The conceptualization of floating habitats in Venus' upper atmosphere necessitates the development of innovative materials and engineering solutions. Designing structures that can withstand corrosive acidic conditions, turbulent winds, and extreme temperature fluctuations requires a new frontier of materials science and engineering ingenuity. While the surface of Venus is inhospitable, some scientists have explored the idea of colonizing the upper atmosphere. At altitudes of around 50 kilometers, conditions are more moderate, with temperatures and pressures closer to those on Earth. Floating habitats in the clouds could potentially offer a more feasible environment for human exploration and habitation. Venus remains a subject of scientific exploration and study. Advanced technologies and spacecraft missions can provide valuable insights into its geological, atmospheric, and climatic conditions. Continued research contributes to a deeper understanding of Venus and informs future considerations for human missions and potential habitats. The concept of a cloud city in Venus' upper atmosphere involves constructing floating habitats at altitudes where conditions are more Earth-like. These habitats could utilize the buoyancy provided by the dense carbon dioxide atmosphere. While this concept offers a potential solution to the extreme surface conditions, designing and maintaining such structures present formidable engineering challenges. Despite the inhospitable surface, scientists explore the possibility of microbial life existing in Venus' upper atmosphere. Studies indicate the presence of phosphine, a gas that on Earth is associated with microbial life. The search for signs of life, even in the most extreme environments, remains an active area of exploration. Venus lacks a global magnetic field, a protective shield against solar wind and cosmic radiation. Earth's magnetic field plays a crucial role in shielding the atmosphere and surface from the harsh effects of the solar wind. The absence of this protection on Venus exposes its atmosphere to erosion by solar wind, affecting its habitability. Venus has experienced extensive volcanic activity, evidenced by vast volcanic plains and numerous volcanoes. The continuous volcanic eruptions release gases into the atmosphere, contributing to the planet's extreme greenhouse effect. The potential for ongoing volcanic activity poses additional challenges for human settlement. Thanks for watching. Please like, subscribe, comment, hit the notification bell, and share to be notified when we add new content.